Good morning, everybody. My name is Hobie Sears. I work with a company called Probo Medical, and we do work in the ultrasound world, the DI world, and we also do repairs of ultrasound transducers and endoscopy probes. And we're going to talk today about proper care and handling of TEE transducers and endoscopy probes because there is a lot of similarities in how these probes are made and the kind of problems that affect both of them. So we'll kind of dive right into that and go from there. So topics to be covered today. So why caring for your TEE probe and your endoscope? Why does it matter? And then some risk factors and talking about the anatomy of these devices and kind of how are they built. Go over some basic terminology concepts, that kind of thing. So we kind of always know what we're each talking about. And then the basic rules of care. So how do we go about what's kind of the baseline of care for these items? And part of the reason we're doing this, all in all, you all don't have any gain here. It's not your responsibility to take care of these probes. But where it comes to it is it could be your responsibility to educate your users on how to go about this and the things that now you can say you've seen, quote unquote, and the kind of damage that can occur. I can tell you on the endoscopic level, I'm not exactly sure what percentage of repairs are being done based on damage. But in the TEE world, 98% of the problems that happen to a TEE probe are damage. So when we talk about warranties on a TEE probe, 2% of what comes into our facility gets covered by warranty. So that is a really, really tiny number. And most of these problems are fairly avoidable. And we know that's true. I actually take a version of this talk and go into hospitals and deliver straight to end users or the people that are in the area where they do the sterilization. For some reason it's skipping my central sterile, reprocessing, whatever you want to call it, and even the physicians. And so we have a talk that goes directly to them. And when we go into the facility and do this talk, and that's usually a facility where they are going through quite a few probes. When we go into these facilities, and they listen, and we get access to central sterile, the sonographers that are helping with the case, the doctors, be it cardiologists or anesthesiologists or whoever might be using the endoscope. Once we talk to them about all the problems they have, we see the problems literally drop off to almost zero. And that usually stays that way until there's a significant turnover in personnel, generally related to central sterile because they turn over personnel, same in other areas, I'm sure. Most everybody is that. So let's kind of move on. So why does proper care matter? And we probably all get the general idea of why it matters. Many failures are preventable. That's just the basic truth of it. The better you take care of your equipment, the longer it will last. It does save time in the long run. Some people say, well, you know what, if we're spending all this time being super careful, doesn't that slow us down? It does a little bit, to be honest. Maybe you're just a little bit more careful. Maybe you're doing some extra inspections, take a few minutes here and there. But how much more time does it take when all of a sudden you're down a piece of equipment, you got to find another one, or you got to go through the hassle of even calling you guys, telling you, hey, we got to come get a probe, and it says probe, we'll get it handed off to you, et cetera, et cetera. In the end, getting things fixed is more of a hassle than just taking care of it, almost with anything. Same with your car. It's better to go get oil changes than to never change the oil in your car. For the most part, it doesn't work out well. So definitely saves your department or your hospital money. We all know today, as much as we talk about patient care, we're going to talk about that in a second. Saving money is one of the things that folks in our industry are tasked with doing. We realize that. So, but most importantly, the better the condition of your devices, the better the outcome, and the safer it is for the patient. And that's pretty serious. One of the things, I always tell this story, our TEE probe repair center is in Tulsa, Oklahoma. And one of the most technical things we do, it seems in Tulsa, Oklahoma, which doesn't seem to be the technical capital of the world, but these people are fantastic at what they do. And there's in their shipping area, and I assume the note is still there. I was out there about 4 years ago, and it was, and it just said right above the shipping door, you can't use it on your grandmother if it doesn't ship. And it's handwritten, and I'm like, you don't need anything else in your whole company. Just say that, and that's what matters. So some basic rules of care. So first of all, don't drop the TE probe or the endoscope. It may sound simple, but it's one of those things that if you hear it, it kind of reinforces the idea that I need to be careful with this device all the time. Don't let the tip, and we'll talk about this tip, and it's often called distal tip. And it differs between endoscopy and TEE. We're going to talk about that a little bit, kind of what's in both. But basically, everything in the endoscope is built to support this distal tip. The distal tip is incredibly fragile as well. And so don't let it bang into anything. You're going to see some pictures of what happens when you do that. Don't wind up the insertion tube too tightly. So these TE probes and endoscopes, they are flexible. And the ones, in this case, we are talking with the endoscopes, we're talking about flexible endoscopes today, not rigid ones. They are flexible, but you can coil them up. And if you coil them up too much, you can actually bend them. We don't want to do that. Always carry in a hard-sided container. 20 years ago or more when I got into this, and we started seeing a lot of TE probes, people used to put them in pillowcases and carry them around the hospital. And that was considered to be like grade A protection. Well, also these TE probes back then were way more durable. They were much bigger. I mean, so big that patients could barely breathe when they were inserted in the throat. And frankly, the TE probes of today are much more fragile because they are designed to be so much smaller. We'll talk about some of the things that go on with that throughout the talk here. But we have always wanted to put in hard-sided containers. It doesn't have to be anything special. You can go to Walmart and buy a bin that's this big, put a lid on it, and carry it in that. Or you can get the very special trays from Civco that, you know, are organized, and you can put the endoscope or the TE probe in a very specific spot, carry them around, and they're very safe. That's all fine too. Just in a hard-sided container. Always use bite guards. Anytime there's an oral insertion, this was the one that's on the doctor, right? And we need them to always use a bite guard. I actually met with some anesthesiologists, probably been about a year ago, and we have traced back their problems in many ways to bite guards. And so they knew they were kind of on the hot seat. And these guys were great. I mean, they were very honest, and they told me, hey, we have been reluctant to use bite guards, especially in cardiac surgery, because it's such a long time. We were afraid we were going to cause J problems for the patient. And he said, but, you know, about 2 to 3 months ago, I started using bite guards, and I'll be honest with you, I've asked every patient, not one bit of joint pain in their mouth, nothing. And I said, Doc, that's great. You realize that it was also about 2 to 3 months ago that your hospital stopped having problems with damage. So it correlated perfectly. It's very interesting. And one thing, even if they're in surgery, people are like, yeah, but if they're in surgery, they're completely sedated. How are they going to chew? And sometimes it's not the chewing on the insertion tube. Sometimes it's when they extract it, they drag the insertion tube across the canine. And the canines are sharp, and they just split it open. So it doesn't always have to be something the patient's doing. But if they're just getting a TEE study, they do not get knocked out completely. They're in a twilight, and they will gag. When you gag, you chew. And that can cause it too. So without a bite guard, things can happen. Never allow water to get into the articulation control, we'll show you in a minute, or the connectors. We're going to talk more about water here in just a little bit. And then do not allow what's called the bending rubber. We'll describe that as well, or the insertion tube to be poked with anything. Needles, scalpel, scissors. You have to be very careful. They're durable, except for the bending rubber is not durable. And you'll see why. So let's talk about anatomy. In this case, we're going to look at flexible endoscope anatomy. And I think we'll go ahead and start here at the distal end, so the distal tip. So this is, in this case, in the endoscope, most of the time these days, we're talking about some sort of camera that's going to be there. On the TE probe, it's going to be an ultrasound element. And in some endoscopes, it's going to be both camera and ultrasound at the same time. So a lot going on in that tip. The tip is pretty much, give or take, about the size of one of my fingers here, very small, very tiny. And everything is meant to support that. Right after the tip is this bending section, this bending rubber. It's a very flexible section that the doctors can twist and turn to get better images and to see things. And this is true for ultrasound and endoscopy. So because it is so flexible and that rubber has to be flexible, this is a point of weakness for both types of transducer. Most of the problems that we see with water intrusion, if they aren't caused in central sterile by putting the whole probe in water in certain situations where you shouldn't, it's the problem comes from here. So then after that, insertion tubes are about, on our bending rubber areas, they're probably about that long. So it's significant. And then after that, you get into the insertion tube, which is just the black tube, and it's usually lettered with distance or stenciled with distance. This is a much more robust area of the probe. It's got multiple layers of vinyl, and that's on top of like a chainmail sleeve. And then in that sleeve is all of the wires and instrumentation that is needed to go down to the tip for whatever need, be it ultrasound or endoscopy, that's going on. So we don't see a lot of insertion tubes cut. We do see them bitten. And typically for an insertion tube, this will be somebody that doesn't have a bite guard in, and they actually can get it under a molar. And you'll see some pictures. They can just crush it. They can't really cut through it. I don't think anybody is strong enough to cut through that vinyl with their teeth, but they can still crush it. And after the insertion tube, we have the articulation. In this case, they call it the control body. This allows them to rotate, and there's wires inside there that actually pull the bending rubber and the distal tip into different areas so they can manipulate where the probe's going, get a better image, et cetera, et cetera. And then we've got the cable going out to the light guide on the endoscope for a TE probe. It's just a connection going to the ultrasound machine. Those are pretty similar. So at the end of the distal tip, though, when it comes to endoscopy, as we said before, primarily a camera, sometimes also an ultrasound element. And these are one of the things that we see get damaged the most. And these are tiny little CCD wireless video connectors and camera. Very much so. The CCDs really incredibly small, 2 to 3 millimeters. These are all practical purposes very similar to the cell phone camera. Although your cell phone camera might actually have more defense against damage than these do. That would probably be, Apple probably protects their camera a little bit more than these do. But that's kind of like it. Each one of these cameras also has several lenses. So you don't just have a chance to crack one thing, you have a chance to crack multiple. And any one of them that you crack is going to ruin the image. So very sensitive to moisture and impacts such as dropping. Another reason we want to be very careful about handling, that kind of thing. So the video connector definitely in an endoscope is one of the highest failure items for damage. Insertion tubes. When we talk about insertion tubes, and on the left is a picture of various size insertion tubes that you can have in endoscopes. On the right, a variety of TE probes from different manufacturers, and you can see all the insertion tubes leading up to their ends there. So we do always want to inspect TE probes for damage to insertion tubes. Want to keep an eye on that. It is not the #1 thing we see, but we do see it. So here's an up close and personal look at the bending rubber section. And this happens to be on an endoscope, but I can tell you it's almost identical when it comes to TE probes. The only thing that might be a little bit different is the actual wire mesh articulation section that's on the left side of the image there. But when you have this bending rubber, you have this articulation section, and that is there first. Then it is covered with this chainmail section. And this chainmail section is the same kind of piece that runs through the entire insertion tube. So that's kind of there underneath that vinyl the whole way. But what's different here is that we no longer have those layers and layers of vinyl covering that insertion tube, when we get to the bending rubber, it is one piece of rubber tubing about that long, and it is a couple millimeters thick. It has to be super flexible. So this is the weak point. This is the point that is so easy to have a problem. And we'll see several pictures of this. Biopsy channels. This is specific to endoscope. Ultrasound TEs do not extract biopsies at all. So these are the kind of things. They have to be cleaned very well during reprocessing. And anytime you have a collapsed or kinked or scored biopsy channel, it presents a problem that could occur certainly as it's being cleaned, or even in a patient, or it's being cleaned and there's a break in the biopsy channel, and literally the liquid goes into the endoscope and doesn't come back out. So, which is going to always cause problem. Here's a circuit board that actually was damaged due to a leak in a biopsy channel. You can see all the various water damage throughout that. Again, something else that is very specific to endoscopes are soaking caps. So when they're putting the endoscope in to be processed and cleaned, there are certain areas that need to be capped off and sealed with the soaking caps. If not, they're going to destroy the endoscope by putting it in there. But a couple things that need to be checked is there are seals on these soaking caps, and they need to be checked and make sure that they don't have any holes or tears in them. And they actually should be lubricated with silicone oil. Our endoscopy repair lab says once a week. I doubt that happens pretty much anywhere. Just knowing kind of the nature of people. I know I have a pool, and I'm supposed to grease those O-rings like every year, and I don't know that I do that either. Just kind of natural. But and then while it's soaking, that's also when they would do an electrical safety test on it as well. If those caps aren't tight, then water's going to get in there. They're going to also, generally speaking, will fail safety testing. Anywhere else that they just see a seal, there's a lot of seams and that kind of thing where you might see seals, and if they look in between those seams, and it looks like seals are in any way drying out or breaking up, and that should be something that should be preventively repaired before it gets worse. So inspecting endoscopes. So we really talk about this idea of training the users, constant inspection. It's not like it's one person's job to inspect endoscopes. It's everybody's job to inspect. If you touch it, look at it. See if there's something wrong. Because we always say something in ultrasound, and I think it applies really well to endoscopes as well, is repair small and repair quickly, which means don't let things fester. Don't let things sit around. It's not going to get better. There's no chance any of these things fix themselves. And the smaller the problem you fix, generally the more likelihood that's going to work, and it's going to be a lot cheaper. So if we've had people say, oh, well, my probe's starting to do that. I think I'll just wait for it to get worse. Why? The only time you do that is if the probe is not repairable. Like, nobody repairs that probe. Okay, you might as well just use it until it dies. That's a fair statement. Until you check in, make sure that's real. Don't do that. This is an example of an insertion tube that somebody got a molar on it. I can't tell you if that's an ultrasound or an endoscope. This is a insertion tube that something happened to it. I can't really tell what got it, but that took significant force. And that almost looks like something fell on it, or that's probably not caused by a patient. It's probably caused by proper handling somewhere along the way. Okay, on to TEE anatomy. So a lot of similarities, couple of differences, kind of thing. So we're going to start again down here at the tip or the array housing. And so in this case, because we're talking ultrasound, it's always going to be an ultrasound array. So this is very much so like the same kind of array that you have in a surface ultrasound system. or surface ultrasound probe, except for it's just a lot smaller and takes up less space. Right next to that, and you can see it right here, is the bending rubber. And that is very much so, just like the bending rubber we talked about on the endoscope. And then we have the insertion tube, which is nearly identical to an endoscope. Coming up to a strain relief, the articulation and control, and then the coax cable that will go off the back. So one of the things that we talk about in ultrasound a little bit is where everything, like an endoscopy, everything around the transducer is built to support that little camera. In ultrasound, everything is built to support the ultrasound array. So this is the actual array from a Philips X7-2T TE probe, which is nearly identical to the X8. Now they've come out with the X11-4, which I haven't seen the inside of that. I highly doubt they've changed their manufacturing concept. It's just a different crystal with a higher frequency. But people ask us, like, we do lots and lots of repairs on X8s and X7 probes from Philips. I mean, a lot. And people ask us, why are they so easily damaged? And the question comes up so much, we decided to add it to this talk. So inside that distal tip, it's about, the whole tip is about the size of my thumb, and the array is about the size of my thumbnail. Now, if we go back 20, 25 years, I've been in this a long time, TE probes used to be more like that big. And so the array was bigger, there was more room inside there. So what they did, manufacturers actually built waterproofing into the tip of their TE probe. So if water got in there, it couldn't get to the array. Well, when you're that big, there's no room. You can't waterproof it. At least that's what the theory is. So when this is an array that's been extracted out of the ultrasound transducer. So literally we're handling this, and it's a little beat up on the edges just to be handled. But it is, you know, it's the size of my thumbnail in a space the size of my thumb. So there's not really much room around it. So what they do, this is a very interesting thing. Ultrasound crystals are grown. They are not manufactured. They are a crystal, so they are grown. And in the front of this, or well, not in the front of it, on the back side of it, is a little computer chip, an ASIC. So there's so little space they actually grow the crystal on the ASIC. It's actually an ingenious thing. They have a like a grid that's there, and it has flexible circuitry that comes out of it and plugs into the ASIC, and then they grow the array right on the ASIC, which is ingenious. But you see how these wires, this little blow up section right here, comes over here, and you've got these silver wires. What they're doing is they're taking the data off of that grid that the crystal's grown on, taking that data and attaching it to the flex circuit that rotates underneath. Now, so I notice one thing that we don't see on these wires: insulation. Every one of these wires is bare. So all that signal. Now, remember, the whole thing is the size of my thumbnail. So each one of these wires, a little bit bigger than a hair. When our folks take these apart and they actually take the cover off of that, they can't even breathe on it. If you breathe on this, all the wires will lay down. So you can imagine what one drop of water does. One drop of water hits that, or Sidex, or cleaner, and probe is, and that is a probe killer. That probes don't come back with this because nobody else can manufacture that array. So we can fix a lot of things, but when the array's gone, that's one thing we can't fix. So that's really what happens. Bad news is there's no water protection throughout the entire length of the insertion tube, which means you can introduce water on any part of this TE probe, and it will get to the tip unless it dries out before it gets there. So we'll talk about that as we move forward. I think it's people like that more than my talk, always. So, So the articulation control, it's not an area, this doesn't get damaged in and of itself very often. It's actually kind of hard to damage. It's very solid. But coming out of this articulation, there are a couple of wires. They're attached to those wheels, and they literally go through the neck of the TEE. Same with endoscopy. And the doctors rotate it. They can move that bending rubber and pull it in different directions. It works really well. Those wires do naturally fail every now and then, or they get loose, and sometimes they need adjusted, that kind of stuff. Another couple things, anatomy-wise, glue beads. And on endoscopy, I don't see that as much. They seem to handle it a different way. But in the ultrasound world, we have glue beads on either end of the bending rubber. And I used to think that these were beads that got glued in place. They are not. When these are being reassembled, they actually use liquid glue and they sculpt these beads while they're in the process of drawing. So our folks in Tulsa that do this, I got to see them do it, and it is sheer artistry. I mean, because if they even make one of those glue beads lopsided, they have to take that off and redo it, because if there's a bubble on one end, it's too easy to shear off. And so it's really a pretty interesting thing. Okay, so that's pretty much it with anatomy. Now we're going to get into inspecting the TEE, much like we did with the endoscope. We're going to talk about that now. So, but basically, we want to look for any crack, chip, cut, hole in the tip, bending rubber, insertion tube, any cracks in the control housing, which probably aren't going to see cracks in the control housing, but maybe at the strain release. And then the other thing is bent or misplaced pins on the connector. In the endoscope world, connectors are different. But on the TEE world, we see a lot of damage come at the connector. And again, most likely that's happened in central fit. So this is definitely a canine tooth. This is an older TEE probe, but that's definitely, it has such a perfect canine shape. It's great to have in here. I'm not really sure. This looks like it was burnt. I didn't really figure that one out, but looks like somebody burnt a hole into the insertion tube. It's a crushed insertion tube. You can even see the two parts of the molar. Glue bead is missing. So what's really bad about when glue beads go missing, they don't just fall off as a hole, they crack and chip. And so you get these areas where it's really difficult to clean. That's not glue, folks. That's foreign body material. That's material from the previous patient. Now, luckily, the Cydex tends to kill all the bad things that are in there, but it's still disgusting. So. Holes in the bending rubber. So, and this is blowing up significantly. These would be probably very difficult to even see without a magnifying glass. So, this is an example of what can happen if water gets on the wrong two pins on a connector, or maybe some, this can even happen with non-TEE probes. A little bit of gel gets in there. I actually had a sonographer one day do $25,000 worth of damage because that happened. You know, she was one of the best sonographers I've ever worked with as far as having her house in order, like very specific, but just touched the probe, didn't realize she had gel on her finger. It was in there, she plugged it in. She actually told me she heard it sizzle. And when she heard it sizzle, unfortunately, she switched probes and cross-talked all the high voltage to the other probe and killed it too. I'm like, you should have just unplugged it. But, you know, things happen. But one of the biggest things that occurs is water infiltration. And again, this is probably going to be, and I don't mean to beat up on these folks, probably going to be central processing. It could happen in other areas, but that's probably where it's going to be. This is the part of the TEE probe that should be submerged in water when it's being cleaned. The other part of the TEE probe should never even be splashed on. So we call it the high and dry section. We want this part of the TEE probe. The only time water should hit it is on a cloth. And outside of that, so what we do find though, is a lot of times they're doing a pre-clean of the insertion tube and the distal tip, and it might be on a long, like counter that's next to a sink, and then you look down and there's a 1/4 inch of water on that counter, just because they're doing all kinds of stuff and it just gets water on them. These probes most of these probes have a hook right here. That is designed to put on the wall and hook the part that's not supposed to get wet onto something, and therefore it keeps it from getting water in. That's really that's the whole purpose. People ask me, what's the purpose of that lid? That's it. Any water that enters into here, this is not waterproof at all. So you can get in there, you can get in through some of the seams in the metal, or you get water into the connector, and then that connector gets held up higher in the probe, that water will make its way all the way to the distal tip of it. And it'll ruin there are electronics in all the connectors, so it'll wreak havoc there as well. So here's what happens when we see water inside articulation housings or articulation controls. And understand when a TE probe heads to our facility, the first thing that happens is it goes in quarantine for 24 hours. So when we find water, like actual water droplets, there was enough water in there to fend off evaporation for at least 48 hours because it had to be shipped. Sometimes, that could even be longer than that. So that means there was significant water inside there at some point in time. You can see here, there's the little wires for the articulation. And then here's another view of the top. You can see there's wires there. These red dots, when a TE probe goes through our facility, these are actually water activated red dots. So they're not red until actual water touches them, not humidity. It won't go up, it won't go off because of humidity. It actually has to have water touch them. And some people will be like, well, how do you know that there's water in it? Like, well, that went off. Or anywhere there's stainless steel, water marks stainless steel after it dries down. So we'll see that as well. This picture kind of looks like the inside of the electronics, and this is the connector, just is a little dusty. All that dust is corrosion. But what is really interesting about this image is on the casing, we're not seeing like heavy water drops. So this is almost like it was humidity or something that was in there that created just the perfect environment. And this was one of my customers. I remember this picture. And the probe was just doing weird things. So we don't really, Good news is the electronics can be replaced. That can all be cleaned up. They can be replaced. And that is repairable. So. Transportation. We've talked about TE probes and endoscopes needing to be kept safe during transportation. And these are perfect examples of things to use. Whether you can get into the really nice formed ones, or just go to Walmart and get a box. So I was at a hospital, it's probably been 5-8 years ago now. And this hospital was going through a TE probe about a week. And went in there and I gave this talk. And the manager of Central Sterile actually he's like, we have like 12 of these probes. He goes, we need a dirty and a clean box. I'm like, yeah. He goes, so I need to buy 24 boxes? And I'm like, oh, that makes sense to me. He goes, that's a lot of money. I'm like, do you want me to go to Walmart for you and buy these boxes? Because, and I called him out hard on this because he was complaining about spending $100 on a box. When, one repair, the cheapest repair you can get on a TE probe is about $2,500. And you could be talking about a $17,000 to $20,000 replacement. Easy. So, a box. This is what happens when you don't use a box. So, this was a picture we got. Hospital had a probe. Believe it or not, this was a door game. Now, and this is true in ultrasound, and I would imagine it is true in endoscopy as well. And we can't figure out why, but taking a transducer through a doorway is one of the most dangerous things that you can do. And we're not sure why that is. Like, we really can't figure it out. But that's what happened here. And I'm like, are they just standing there waiting for the door to close on it? Or I'm not sure. But like we have a couple hospital systems in Ohio. I'm from Ohio. And they have trophon sterilizers for regular ultrasound probes in every room there's an ultrasound machine, so they don't leave the room because they've decided that it's cheaper. I don't know if it really is or not, but they've decided that. So, so this was the picture that we got originally. That's not repairable. That destroys the probe. So they bought a brand new probe, and 30 days later, they destroyed that probe on the same door. And I was told that it looked like, they're like, you couldn't tell the difference. Like it looked exactly like the first picture they sent. And yeah, we were just totally dumbfounded. So transport damage is definitely an issue. So what preventive measures can people take? Inspection. Inspection is the big, well, it's not the biggest, but it is one of the greatest preventable measures. And again, it goes back to this concept of repair fast and repair small. Don't, and I would say in ultrasound, that's with all transducers. Repair fast, repair small. Follow recommendations for use and cleaning per OEM. That means the chemicals that you're using to process, make sure they are approved. Using non-approved chemicals is one of the fastest ways to kill transducers for sure, and endoscopes as well. So, always use a bite guard for oral insertions. Always have the TE or endoscope in a protective case for transporting. Have the probes tested just to see if you think there's a problem. I mean, we do free testing. We'll take your probe in and evaluate it and tell you what we find. When it comes to ultrasound cables, the cable that comes out of the connector, keep those off the floor. Cables on the floor tend to get stepped on, they tend to get pulled, you can actually rip one out of a machine, those kind of things can happen. And never let water get higher than the insertion tube on a TE. Endoscope's a little bit different, you've got those caps that we're putting on. All right, so resolving. What do you do when a problem is found? Goes back to what we talked about. Don't wait, react immediately. In this case, inform engineering. You guys are engineering, so tell your people to inform you. And one of the things we talk about is if you find a hole in a TE probe after a study, what do you do? Because now we're in this quandary. Probe has to be, like, we can't accept the probe that's not been sterilized. The probe has to be sterilized. It's got to go through that. So what are we going to do? And that would usually take, we tell hospitals to call us. Because what we want to do is we want to make sure we're setting up with our facility in Tulsa that they know this probe is coming. What we don't want you to do is do this on a Friday. And then you're going to send that probe to us. It's going to be the weekend. It's going to get there on Monday. We still have ISO policies that say that probe sits there for 24 hours. So that's 72 hours, and in 72 hours in a high humidity confined environment, corrosion is done. You're ruined by that time. But if it's a Monday through Thursday, we can have this set up. You guys can soak it, ship it. It'll go through the 24-hour waiting period. They'll open the whole probe up, and it's usually ahead of the game. But we have to give them a heads up about that. We have to get a plan. And what we do, you never know. It could be non-repairable at that point. It could be repairable. But that's the best opportunity. Right. I would just hold it. Yeah, I would hold it up until you have the plan. So, and I've never really thought about it. You might even be able to, like, where there's a little area, you might even be able to put like some electrical tape on there temporarily to cover that area. I don't know. It's still interesting. But, yeah. Water is going to get in it for sure. Yeah, I've never really. Yep. Text it. Yeah. No, I don't disagree with that. So, my probe lab might, and I'd say no, because then we have a spot that's not sterilized, but I think that might be a compromise that could be reached. But I think the big thing is, you talk to your local representative, they can talk to our folks in Tulsa. We're not such a big company that we can't pick up the phone and call the guy that runs that department. He'll answer. Actually, it's only about 25 people that are there in that building. And with that, that's pretty much it. Very abrupt. So